we're back. I messed up streaming earlier, but today I'm just going to go through really quick the beginner tutorial we did today to make a platformer in about 30 to 40 minutes, hopefully. Alright, so this is just a preview of what we're going to be making. We're going to have a little cube that we can move around, jump, and yeah. I'll also cover camera tracking very briefly, but yeah, this is basically what we're going to achieve in the next bit. Alright, so let's go ahead and close out of that. Go ahead and open up Unity. Now you can use any version that you want. I'm using the Unity Hub I really should update it, but I'm using that. And I'm probably going to use 2018.2.6, that's the most recent version I have. But this tutorial is backwards compatible with pretty much any version of Unity, I believe. Okay, so I'm just going to name this platformer tutorial, and we're going to change this template to 2D. That's very important. Well, it's not very important, but it'll be important in setting up some default stuff, so your stuff won't look different to how mine looks. Now, I think by default Unity Analytics is on, but I don't want this to save to the cloud, so I'm just going to turn that off. You can choose where to save it, and you can go ahead and create project. So this may or may not take a while for you, but I'm hoping this will be pretty quick, at least for me. We'll see. I'm not sure why it's, I guess because I never really specified what sort of platform we'll be building for. So it's importing every single library that I have installed, but it shouldn't take too long. Alright, there we go. So this is the scene you'll be greeted with when you open up Unity. If it is not, go to Window, Layouts, and then go ahead and choose Default, and that'll reset it to that. Okay, so we have this scene here. What's really going on here? So when you open up Unity, you have a bunch of different tabs that you can go through. So over here, for example, we have the Hierarchy tab. We have the Scene tab over here. If we click on the Game tab, it'll show us what the game looks like at the moment. And one important thing actually about this game tab, I'm going to sidetrack for a second. Notice how it says free aspect here. That means if you're trying to like line stuff up with how the game looks based on this screen, resizing this will change how that looks. So you want to make sure that this is set to 16:9, so you can see exactly what you want your game to look like. 16:9, of course, being the resolution of most modern monitors. Alright, you have the Asset Store tab, the Inspector tab, very important. You also have a Project tab down here. I'm just going to move that out a little bit, which gives you all your assets that are in here. And you can see 2018 by default saves this scene. For you it might be Untitled here, in which case you're going to have to go to File and Save Scene, and you can choose where to save it. It automatically generates a scene folder along with naming this sample scene, so I'm just going to roll with that. And you can see there's a main camera in here. So notice when you click on the main camera, it populates the Inspector tab with all of the components that are currently sitting on this main camera game object. So if we go to our scene, we can see the main camera object, and then sort of the view rect that it has. And again, if you go into free aspect here, this is a lot different. Say we did that, then you can see the bounding box has changed as well. So we want to make sure again that this is on 16:9, or not 16:10, 16:9, so that this box is constant when we're lining stuff up. Okay, and here you can see the background as well. If you want to change that color from that dull blue, I'm just going to change it to black for now. So you can see that changes how the background of the color, or the game is. Okay, so obviously if we're making a platformer, we need something to control. So I'm going to right click in the hierarchy here, go to Create a 2D Object, and I'm going to choose a Sprite. Okay, so I'm going to name this sprite Player. You can notice on the inspector you can also change the name up here. And so you can see the transform component holds position, rotation, and scale. Now any game object that you have in your scene will have a transform component, but since we created a sprite, it also has a sprite renderer component. Now the first thing I'm actually going to do is take this transform component and change all these values to 0. This is just so that the object is in the very center of the screen. You can see the little circle it's drawn right up there. And also you want to make sure that the Z value when you're in 2D is always 0 so that things can actually collide with each other, unless you want them to be in front of or behind other objects in the game. Okay, and a quick way to do that is click on this little gear here and hit reset, and that'll reset everything to these default values. Okay, so currently there's nothing in the game. Like if we go here, there's still no sprite like there should be. So you can see that's because there's no sprite in the sprite renderer component. So you can import your own sprite here, but I'm just gonna right click in the assets menu down here, create sprites, and I'm gonna choose a square sprite for this one. Oh, I'm so sorry. I'm so sorry. Okay, I didn't realize it was echoing. There we go. Okay. That should be fine. Sorry about that. I have my sound off for some great reason. It's because my headphones are not plugged in. Yeah, thanks for that, Santiago. Alright. There we go. Now my headphones are plugged in, so I can now no longer hear that it was echoing because I turned that off. Okay. So we have this square sprite here that we've created. Now if we click on the player object, bring up this menu again, we can just drag this square sprite into the sprite container right here. You can also do that by clicking on this little circle next to the field, and that'll bring up this menu. You can choose to select the sprite. Now you can also mess with some other things here. You can mess with the color. I'm gonna maybe set it to a nice like bluish color, you know, something nice. It'll stand out from that dark background we have up set up. And so now how do we make this object move? Because right now we hit play on the game. Can't really move the game object in any way. So this is where we're gonna start scripting. So we're gonna go ahead. We're gonna right click in the assets menu, create a C# script. We're gonna be coding in C#. This C# is very analogous to Java. There's just a few syntactical differences. And I'm just gonna name this script player movement. You can name it whatever you like. And I'm gonna hit enter on it to open it up. Your IDE may take longer to open up than mine. I have it set. I'm using Visual Studio Code, but I think by default it tries to use MonoDevelop or Visual Studio. So feel free to pause here to get that the IDE open before we begin scripting. All right. So by default, Unity creates this sort of template for you. For any script that you create, you'll have a start method, an update method, and then these three namespaces. These, if you're familiar with Java, is just importing like libraries. And then any script that you're writing that is supposed to sit on a game object in the scene must inherit from auto behavior. Otherwise, you cannot add it to that game object. Okay, so update is pretty self-explanatory. It's called once per frame, and this means that it's called more when you have a higher frame rate versus less when you have a lower frame rate. So this is really what handles like smooth movement throughout games. So like if you have a low frame rate, it hopefully wouldn't stutter versus having a high frame rate. And we'll see later an example of this. Okay, so we're gonna go here, and the first thing we sort of need to start moving our player is how fast do we move. So I'm gonna go ahead and create a public float. A float is just a double, but actually I learned this today. Floats are, so doubles are basically double the size is what so there's integers, which are a certain amount of memory, and then there's longs, which are just longer integers which take up more memory. Doubles are the longs to floats are to integers. I think that's the best way to put it. But anyways, let's ignore that. Let's move on. Public float speed, I'm gonna set this to about 9 just by default. Keep in note, any public field you make here, if you go back to your inspector and you click on the player and then you add the player movement script that we just wrote, you can see that it has this speed variable now that we can mess with. And since we can mess with it here, any changes you make to it here will not be reflected in there. So if we say change this to 10 and hit save, this will not update to 10. This will stay at 9. This is to make it so that if you need to change variables, you can change them from here, and you don't need to go back and change your code and recompile it every time. Okay, so now that we have our speed variable, we can start moving. Movement is really easy in Unity, at least. So the first thing we're going to do is we're going to get the input of the players, so what buttons they're pressing down and stuff like that. So I'm going to create a vector3 and call it input, and the vector3s are just a collection of 3 floats. So it's basically just 3 of these objects, and so it reduces the amount of clutter in our script here. So I'm going to create a new vector 3, and we're going to do input with the capital I. That is the Unity class for handling all of the input stuff, like controllers, keyboards, all of that. And we're going to do getAccess raw. Now the difference between getAccess and getAccess raw is that getAccess applies some default smoothing when returning the value, whereas getAccess raw just returns the raw movement data. And we're going to want to get the horizontal axis, so whether they're moving left or right. And then for the other 2 floats in this, we're just going to use 0 for now. Okay, so what is this horizontal? Like, how does it know which keys are moving in the horizontal direction? Well, if you go back to Unity, you go to Edit, Edit Project Settings, and then Input. You can see here that there's this axes drop down. If you click on that, there's 18 ones by default, and this one is horizontal. If we fold that out, we can see that the negative button is left, so that's the left arrow key, and the right arrow key, and then A and D are alternates. So you could use WASD or arrow keys when controlling this character. And if you name 2 axes the same thing, they'll just be counted as double controls. So this one's also named horizontal, but this one handles the joystick input for horizontal. So that's just useful to know. You can set up any number of axes you like here, or delete some of the ones that you don't need. Okay, so we have input here. Now, how do we move? So we're going to go and type in transform. Now, this transform is a direct reference to, if we go back here, this transform component that is sitting on every game object. But in specific, since this script is on this object, it's referring to this transform in particular. Okay. Alright, so we do transform.translate, which is a method built into transform components, and we have to give it a vector 3. So if you're familiar with vector mathematics, it's just the vector in space that we'd like to move to. But if you're not, then it's just a collection of 3 floats. So it's x, y, and z. So the amount to move in x, the amount to move in y, and the amount to move in z. So input.getAccessRaw returns a value between -1 and 1. So this x value, so the amount we're moving on the x, so sideways, is between -1 and 1. So if we just give it input, then it'll multiply, and then we want to multiply it by our speed. So this will scale that -1 to 1 out to our speed, which was 9 here. Of course, it doesn't matter that we change it here. I just like to remember what the default value was. So this will scale it out by 9, so it'll be between -9 and 9. So we can move that much on the x-axis. And then it's 0 on the y and 0 on the z, since we're only trying to move left and right at the moment. And then we're also going to want to multiply by time.delta time. Now this is the value that is the time between each frame. And what that does is it makes the movement smoother. So if you have a lower frame rate, your movement isn't choppy. And if you have a higher frame rate, you don't just go faster than people with lower frame rates. So this will smooth everything out that we need. And generally, if you're doing stuff in update like this, you will generally want to multiply by time.delta time. Okay. So let's go ahead and try this out. So if we go ahead, go back to our scene, hit play. Look at that. We've got a moving object already. Now obviously with a platformer, you have gravity, right? Like your player will eventually fall down onto a platform and then you jump to the next one. That's generally what platforms are all about. Right now we're just moving left and right. There's no gravity. So for physics in Unity, well, the main component that handles that, and unless you're writing it yourself, is the rigid body. We're going to use the 2D variant because we're in 2D right now, and we're going to be using 2D colliders as well. But if you're in 3D, a rigid body is what you're looking for. But since we're in 2D, rigid body 2D. Now this will give physics to our object. So just by adding that, if we go back and hit play, our player falls. So we probably want something to catch our player, right? That seems like a good idea. So let's go ahead and create another sprite. Again, resetting the transform on this so it's not behind anything. And let's call this ground. Now I'm going to give it the same square sprite that the player has, and I'm going to move it down. So you can switch between tools. So this is the move tool. Up here in the top left, there's the free move tool. This is the translate tool, the rotate tool, the scale tool, the free transform tool, and then everything at once. Okay, we're going to use the translate, and then the keyboard shortcuts for those are just Q through Y, Q, W, E, R, T, Y, respective to each button. So if I want to go scale, R, translate, Y. So I'm just going to drag this down, and then use R to scale it out, and maybe make it about that big. That seems about good. Okay, and maybe, why not? Let's give it a nice dark green. It seems like a good ground color. Okay, so we have this. Now we hit play, and it should work, right? Nope, we just fall right through it. So the issue here is that we haven't told these things that there should be colliding. Like the player has physics, and the ground exists, but nothing exists that tells the player that the ground is where it should stop. It kind of just goes past it. So what we need to do is add a box collider 2D to this. You can see that generates this faint little green outline around the object, and that is the collider. So anything that touches this that has a collider will stop on, or will collide with this object. Okay. Now that also means that our player needs a collider. So let's go ahead and give that another box collider 2D. Of course, if you're using a different shape than a square, you might want to experiment with the other ones. If you have a very wacky shape, try a polygon collider 2D. That'll try and do its best to map out the shape of your sprite. But this will work for now. Okay, so we have, it catches us. Perfect. So now we can move around on this. We're all having a great time. Yeah, cool. Okay. Now, the next sort of big thing that we need is the ability to jump, since this is a platformer after all. So what I am going to do is I'm going to go back into our player movement script, go ahead, go down here, and make a public float jump force, and set it to maybe 7 or something, I don't know. So this is just how high do we jump. And this is another public variable, so we can control this from the inspector as well, and fine-tune it as we see fit. Okay, so how do we detect jumping, right? We want to go if input, again, because we're trying to find out whether the players hit a button or not, dot get button down, and then we're going to give it jump as a string. Now if you remember back to where we got this horizontal value from, jump is also a default Unity axis, and you can modify the value that you want, or the button that you want it to be. By default, it is spacebar. So then, if we jump, then we can jump. Okay, so now jump is not a method that is built in. That is something we're going to have to write ourselves. So I'm going to go down here and write void jump. So void just means that this method doesn't return anything. Okay. Now, if we jump, then the easiest way sort of to do jumping is when you have a rigid body, is to just do, grab the rigid body and add force to it. But of course, how do we get access to this rigid body component? We don't really have a reference to it anywhere. So we're going to make one. So I'm going to go down and do private not transform, rigid body. That's the one we want. Make sure it's 2D. And I'm just going to name this rigid. You can name it whatever you like. But I just go with rigid. So this is the rigid body 2D component, and now we need to actually assign that. So if we made this public, it would be a field, but I don't need it to be a field, since I'm just going to do it here, where I say rigid is equal to get component. So this will go on the object that this script is attached to, and try to find a component of the type rigid body 2D. And then since it's a method, we need the parentheses and a semicolon. So this will go and try to get the rigid body component. Now, if we don't have a rigid body 2D on an object that we add this script to, this would return null, and then any calls to rigid would thereby throw an error. So one thing you can do to make this safer is to go at the top and make sure that this class requires that component. So the player movement, whenever it's added, will require the component that's of type rigid body 2D. So if there's no rigid body on the object, it'll automatically add one. Cool. Okay, so now that we have access to our rigid body, we can simply go rigid.add force, and then the force we want to do is a force in the up direction. So vector2.up is simply an arrow pointing straight up, basically. So it's 1 in the y direction, 0 in the x direction. So we only move straight up, and then we're going to scale that vector out by our jump force. And then make sure to do force mode 2D dot impulse as the second parameter to this call. Now what the difference between impulse and then the other force mode, which is force, is that force is applied gradually. So you'd have to do it something like update, so gradually speed up the player. Whereas impulse is like a shock or a kick to the system, where it will suddenly apply that force, and you'll have a jump sort of simulated for you. Okay, so now if we go back to Unity, hit play, and we hit the spacebar, you can see we jump. But if you keep hitting the spacebar, you can see we just keep going up. So how do we tell Unity that we only want to jump when we're on the ground and not in the air? That is what we're going to fix right now, actually. So on our player, we need to find a way to tell Unity that this is the bottom of our player. So I think the quickest and dirtiest way to do this is to right-click on the player, go down and create empty. So right-click on the player, not the hierarchy itself, the player, and hit create empty. And that'll create this game object that's underneath the player. You can see there's a little drop down. That means it's a child of the game object. So if we move the player around, the game object will move with it. Okay, so I'm going to rename this to ground check. And I'm also going to move it to where I want the bottom of the square to be. So in that case, if I just move this down to, like, say about here, or if you want it to be exact, you could do -0.5, since this is a 1 by 1 square. So yeah, just anywhere near the bottom, and that will be fine. Okay, so we have this ground check here, so this is where we're deciding the ground should be. Now we need to sort of get access to this object so we can find its position and then start doing stuff from there. So I'm going to create another public variable, and this one is going to be a transform. So this is trying to access this component on this ground check, so we can get its position mainly, but also if we needed its rotation, and maybe even scale, but I don't think scale is very important for this one. So I'm just going to call this ground check as well. And we also want a float for the radius in which we want to check around that position. So we're going to be checking in a circle around that position to see where, if we're colliding with, it's underneath us with anything that is tagged as the ground. And how do we know if something is tagged as the ground? Well, we need a public layer mask, and I'm going to call this ground layers. So anything that's within a layer that we've tagged as ground, and that's within this radius of the ground check, that if we're colliding with something like that, we can jump. If not, then we cannot. Okay, so now we need to go and initialize these. So if we go back here to our player, we can see now that there's this ground check that says none transform. There's a ground check radius that's initialized to 0.5, and this ground layers that is nothing. So we can see there's all the layers that are in the scene. So if we click on our ground object, you can see that the layer it has up here in the inspector is default. We actually want to change this. We want to add a layer to the layers that exist in Unity, and we're gonna call it ground, but of course you can call it anything you like. Okay, so now that we have this layer specified as ground, we can go back to the ground object and we can add it to the ground layer. Cool. Alright, so now we just need to tell the player that the ground layers are the ground. Okay, now we need to tell it which one the ground check is. So this ground check here, we're going to take this and then drag it in to this slot for the ground check right here. So you can see that recognized that the ground check does have a transform component, and it's accessing that. And just to be safe, so say you forgot to drag the ground check in, I'm going to go back into the script, and in here I'm going to say if ground check is null. So say we forgot to assign it in the inspector, then we can do transform, so the transform on this object, dot find. So it'll look through all of the children of this object and try to find one named ground check. And that is what I named it in Unity as well. So this transform will try to go through all of the children of the object. In this case, there's only one, and it will try to find the one named ground check, which is what is named here. So this is just an extra layer of safety in case you forget to assign the ground check. Okay. So now, in here, so we have access to where our ground is. We know what the ground layers are. We know how far in a circle that we want to search around. So now we need to actually do that. So I'm going to create a boolean here. Booleans are true or false, and I'm going to set this to false. So this is just a boolean saying, are we on the ground? And by default, we are not on the ground. And then we only want to do this rigid.add force if we're on the ground. So if on ground, and then we're going to move this statement up into that if statement. Okay, so if we're on the ground, then we add the force to jump. Okay, but how do we change this on ground variable? So what we're going to do, we're going to create an array of collider 2Ds. And what these are just like the box collider 2D that we added to these objects. So you can see that there are other types of colliders. So if you go back here and try to add a collider, you can see all these different types of collider 2Ds. So collider 2D is just a generic type, and so we don't have to specify box collider, sphere collider, or circle collider, and so on. So I'm just going to call this colliders is equal to physics 2D dot overlap circle all. Now the difference between overlap circle and overlap circle all is that overlap circle all returns all the colliders that collided with this versus just the ones that are contained within the circle, I believe. And the non-alloc basically just handles memory usage. So if you're calling it very frequently, say an update, then you're going to want to use non-alloc so it doesn't like destroy your memory. Okay, and so this one takes in 3 parameters. In this case, actually, it does take more, but we're only going to give it 3. We're going to give it the ground check's position. So that ground check child that we have that's positioned at the bottom of our player. We're going to give it that ground check radius that we define to be around 0.5. You can obviously make it smaller or bigger depending on the size of your player. And the layers to which we consider the ground. So this will find an array of colliders that are in the ground layer set in that radius of a circle with the center centered at this ground check position. Okay, so now we need to do a loop. So we need to loop through all of these colliders. I'm going to use a for each loop here. And the way to do that in C# is to create for each collider 2D, say call. You can name it whatever you like again. In colliders. So as it basically reads, for each collider 2D in this array of collider 2Ds, which we will refer to as call for each one, if the game object of the collider is not equal to this game object, so the collider is not this player, so we can't jump off of ourselves, then we are on the ground. So yeah, this check just prevents us from jumping off of ourselves. So if we tagged ourselves with the ground layer, say you made a game that you could jump off of other players, you don't want to be able to jump off of yourself, so this prevents that. Okay, so we have this on ground equals true, and then if we go back to Unity and we go ahead and hit play, you can see that jumping now works. Spamming it no longer makes us jump infinitely. Yeah, there we go, jumping works. Now one thing I will say is that it is very floaty. It takes us forever to come back down. You can notice that. So you get a lot of airtime with these jumps, and there's no difference between tapping the spacebar or holding the spacebar. Both the same amount. And it's actually very easy to fix, and I'm going to go ahead and do that right now. Okay, so for this we're going to create 2 more floats, and I'm going to call this maybe fall speed. I'll set that to like 2.5 by default, and we're going to create another float and call it low fall speed, and maybe set it to like 1.5, something like that. Okay, so these will be used in update, where we're going to check if the velocity in the y direction of the player is less than 0, so say we're falling, we're moving downwards, then we want to basically speed up that falling. So we're going to add to the velocity. We're going to add that vector2.up again, which is just the up direction, times physics2d.gravity.y. So the gravity in the y direction, which by default is the same as the real world gravity in the y direction, which is negative 9.8, around about that, times the fall speed variable we just made. And again, since we're in update, we gotta multiply that by time.delta time. Alright, so that'll speed up the falling of the player. Else, if we're actually rising, so we're jumping upwards, but we're no longer holding down the jump button. So we say we've tapped the spacebar, this is what this is checking for, then we want to basically terminate the upwards velocity and start decreasing that. And now get button versus get button down. Get button down returns true only on the frame that the button was pressed, whereas get button returns true if the button is being held down as well. It will return true for all of those frames. So here we're going to basically do the same thing, so I'm actually just going to copy and paste that line, but we're going to change out fall speed for low fall speed. Okay, so I'm just going to leave this up for a second longer if you need to pause. If not, I'm going to move back to Unity. And if we go ahead and hit play, you can see now when we jump, we do a little short hop, and if we hold down the spacebar, we stay up for longer. So you can hold down the spacebar to jump for higher, and you fall down much faster. You don't stay in the air forever. It feels a lot better to control. And of course you can apply your own smoothing, mess with these values until it feels just right for your game. Awesome. So now there's two other things I wanted to mention as part of this. One thing is prefabs. So obviously a platformer is very boring with only one platform. So let's go ahead and duplicate that. And maybe just move it over like that, thereabout, something like that. So now, if we go hit play, you'll notice this jittering issue. Now, I can create code to fix this, but it's sort of beyond the scope of this tutorial because I'm trying to keep it simple. But I can write code to fix this jittering issue. But for now, let's just see. Alright, so we can jump over, we can basically have a great time. But say, you know what? I don't actually like dark green. I want it to be light green. I want it to be like that color. Now, if you had a bunch more ground objects in your scene, you'd have to go through manually and change the color of each one, and as a result, it gets very annoying. So instead, that's where prefabs come in handy. So you can make a prefab by taking this ground and just dragging it down into your prefab, into your assets folder. So again, just taking this and dragging it into your assets folder. You of course put it in a folder if you like within the assets folder, but just dragging it into somewhere in some subdirectory of the assets folder. That'll create this ground prefab. You can see it's .prefab that basically holds this data for you. Now we can take this and drag this into our scene wherever we like. And say we want to go back to a darker color a little bit. Now we don't have to go through and change all of these. Instead, you can see that there's this new prefab menu in the inspector, where if we go ahead and hit apply, it'll apply it to every ground object in the scene. Now, position and rotation do not get applied, but scale does. So if I scaled this down a little bit and hit apply, that would also scale this one down. So be a little careful with hitting apply. Make sure you've made all your changes first before scaling stuff and like basically creating your level. Okay. And then the last thing is the camera doesn't follow the player. Now, the quickest and sort of dirtiest way to do this is to just go in here and just drag the main camera underneath the player in the hierarchy. So basically making the main camera a child of the player object. And now what that'll do, remember what I said about children, they move with their parent. So you can see, oh, look at that. So I actually forgot to do one main, very big important thing. On the player object, this rigid body, it does give us physics, but that also means that our player can rotate, and we don't want that. So we're going to go into our rigid body, unfold this constraints menu, and make sure to freeze the rotation. So this Z rotation is frozen. So now we will never run into that issue again where we sort of clipped into the corner and rotated, and then everything was just painful from there. So yeah, now the camera follows the player, very basically. I recommend writing your own camera tracking, but this will work pretty well for most games. And of course you can move the main camera up or down to get different effects. So you want the player to be closer to the bottom of the screen, you can do that. And remember that any changes you make in play mode do not save. So if I go ahead and hit play again, the player is still in the center of the screen, not at the bottom like I moved. So one way to actually go about changing that is, say I move this up a little bit, I can go ahead and hit copy component here from the gear again. And if I hit play, you can see that value resets back to 0. But then I can just click on the gear again and hit paste component values, and that'll remember which ones. Unfortunately, you can only do that one component at a time, but it's, you know, handy to keep around. Okay, that is the basics of a platformer in Unity. Now, this may seem very complicated, but I promise you that there's not a lot of coding knowledge that you need to get into making your own games. A lot of this is just if and some for loops maybe. The rest of the Unity coding is just learning these different components and then what values of them to change. So like these colliders, this rigid body changing its velocity, learning about these add force methods, and all of these helpful things that you have. And as an example, maybe we can do this really quick. You can add this component called a trail renderer. So if we go ahead and play now, you can see that there's this trail that's rendered. Obviously it's pink because we haven't assigned it a material, which we can go ahead and do now very quickly. I'm just going to give it the default sprite material, and I'm actually going to change this from 5 to like 0.3 so it doesn't last nearly as long. And of course you can mess with this to do whatever you like. I'm going to add a key at the very end here and drag that down to 0. So now if we go and hit play, so we have this little neat little tail following, and obviously it's a little jittery because it's pretty short. You can mess with it again, and it's also 1 to 0, or you can like lower this even to like down there, and you can see it's a shorter tail. You can go in this color, this gradient editor, and maybe make this color like a nice dark blue, and you can see now that there's like a dark blue to white gradient. And you can mess with the alpha levels as well if you wanted to go become transparent as it went. So over here you could set the alpha down to 0, and then you'd be left with this sort of trail. So of course there's a lot of stuff you can mess with here, and that's why, of course, since we're in play mode, we're gonna have to copy this component, go back here, and then hit paste component values so it remembers that we wanted that. So yeah, that's sort of the basics of the platformer. I'm actually gonna set this back to 1. I like it at 1, even though it's a little jittery. Yeah, there's a platformer. You can mess with the levels, you can create those however you like. I'd also recommend, very quickly, last thing, I promise, I'm not going to keep adding on to this tutorial. If we go to YouTube, actually, if we go to YouTube and look up the Unity 2D game kit, sure, why not this one? It basically just has ready-made assets. I can link at this somewhere. But it has ready-made assets for you, so you can just focus on level design and stuff if you don't feel like coding your own game. So I highly recommend just looking into Unity's resources, the tutorials, and you know, messing around, making your own projects. I think one of the best ways to start is to try and copy one of your favorite games. Of course, keeping in mind scale. Like, don't try to copy an RPG. Try to copy some smaller game like Super Hexagon is what I started with. And just try to make a copy of that, seeing how they did stuff and learning your way around Unity. But yeah, that's the beginner platformer. Thank you guys for watching. Hopefully this was helpful. I will post the commented version of the script somewhere on the Discord or on Facebook. I don't know exactly. Probably both. But yeah, that is the platformer.